All right, it's start time. How's everybody doing? Good, very excited. It's the end of the day. I'm glad you're here. If you fall asleep, I won't hold it against you because I'm kind of asleep a little bit as well. Nobody went out, drank too hard last night, maybe, hopefully. All right, maybe a little. Fair, fair. My name is Hampton. I am a 20-plus year builder, not of the .NET ecosystem. So when you see .NET, C# stuff up here, just know I'm an outsider who likes to break things. So you're going to see some things that you're like, I would never write it like that. That's OK. I did, and I don't know. But I know why it breaks. This talk came out of another one. I'm giving a talk tomorrow on the OWASP Top 10 for 2025. I don't know if you guys know OWASP, but they are late on their delivery of the top 10 for 2025 by like 2 years. So I keep having to make up stuff to give the talk because it hasn't released, but it's supposed to release next month. That's what they say. And part of the research for this talk tomorrow on .NET was just sort of seeing what it is that the .NET ecosystem constantly seems to deal with. And deserialization kept popping up over and over for like the last 20 years. So I kind of dug into it, and this talk came out of that. During the research, something really interesting happened. SharePoint, I don't know if anybody's noticed that that happened this year. And then right after SharePoint, I'm sure anybody here from Microsoft tired of hearing about SharePoint? I'm sure you are. And then after that, you get Sitecore, which is also the very similar vulnerability. So I think this talk comes at a good time. So let's hope I do it some justice. OK, so deserialization is pretty straightforward. If you take untrusted data and deserialize it, you're going to end up getting object creation that you did not expect. And inside the ecosystem, you have gadget chains that allow me to link things together and end up with remote code execution where you would have never expected it. In the beginning, we swore that deserialization of JSON data was very safe. Turns out we were wrong. The object creation has a lot of side effects. So we've got constructors, setters, deconstructors, or destructors, excuse me, type confusion, and then, like I said, the gadget chain. So, and this is universal across all languages. So Java, Python, PHP, and Ruby all deserialize and reserialize, and it all has the same general vulnerability if it's not handled correctly. So if you feel like this is not your vibe, let me give you the TLDR for the entire talk. That's it. So if you're worried about what could happen with this, just remember and go forth. So the key is always validate everything, sanitize everything, don't trust anything. And this goes for anything, not just deserialization. You'll see in SharePoint that the issue was like threefold. The first was that access, the bypass of a protected page. And that bypass came because of a change of a referrer header. And that referrer header is completely controlled by the user. So if it's controlled by the user in any way, you can't trust it. So all right, we'll get to that. OK, so these are the ways that it can go down. Type confusion, right? I thought I was getting a string, but I somehow got a process object instead. Gadget chains, so innocent framework classes being chained to execute code. And then resource exhaustion, right? Deeply nested data crashes my service. That's basically what would happen with Newtonsoft, JSON.NET. It's what ended up giving us a CVE for the first time. So that happened. We'll get to that. Took about 6 years, I think, to get a CVE. All of these are basically trusting untrusted input to tell you what to do or tell your app what to do. So deserialization is very simple. It's user input, your code, created objects. The user gets to specify what kind of objects get created, what constructors get to run, and what memory gets allocated. And this is ultimately the ultimate violation of never trusting user input. The nice part is the community response has been really good. A little slow, but really good. So Microsoft deprecated BinaryFormatter. That was .NET 9. Doesn't help legacy code, but You also now have System.Text.Json instead of Newtonsoft, right? That's the default. You've got code analyzers to warn you that this is in your code. The community has published guides and documentation, and the ecosystem, honestly, it reacted very well and acted, recognized it, but the reality is legacy code persists, right? And legacy code is the favorite of all attackers. So I started to figure out, like, how bad is the problem now, 2025? So let me show you. Let's start with BinaryFormatter. It's the first thing I ran into, and that's because it's been around for 22 years. So let's look at that journey. Timeline looks like this. 2002, .NET Framework shipped with BinaryFormatter, right? Serializing .NET objects to binary. It just works, so people kept using it. Became a standard. And researchers started finding flaws in deserialization. This actually came out of Java before it came to .NET. There was a great talk in 2015 about this at Black Hat. If you ever get a chance to watch it, I have resources I'll share with you, and you can look at it. It's a good talk. Ultimately, patterns emerged that deserializing untrusted data ended up leading to remote code execution. So security people started paying attention. Attackers started paying attention. This was the talk, actually 2017. Excuse my time blindness there. This was Friday the 13th, or the attacks. Basically, this was widespread awareness of .NET started to happen, or just .NET deserialization started to happen. The researchers on stage demonstrated the BinaryFormatter gadget chains, wrote a tool, YSO serial, that still exists today, that still works today, that you can create payloads from a command line to exploit deserialization in .NET. So type confused delegate was the favorite for the most part. 2020, it was deprecated or basically made obsolete in .NET 5. There was a warning that went out in the compile input or the compile output about it. ASP.NET Core throws an exception called not supported. And then the clear message from Microsoft was, please stop using this. Between 2022 and 2024, there was a stronger push from the community, so stronger warnings in .NET 7, .NET 8. Community ended up pushing for migration to get away from it. And then finally, it was completely removed in .NET 9, so no opt-in, no flags, the infrastructure itself was gone. So it took 22 years from its introduction to its removal. That's 22 years of open vulnerabilities. 2025, this basically shows that it's a zombie, right? We got a CVE for a screenshot tool called GreenShot. Does anybody use GreenShot, right? Well, 3 million plus people used GreenShot, and there was a version that is vulnerable to this. And the reason why is because GreenShot was running on a .NET framework for something, right? It wasn't running on the latest version. It was last updated in 2019, but it will be supported until, anyone know when the support date is? 2034. So .NET 4 still supported until 2034. It uses BinaryFormatter for inter-process communication, so IPC uses BinaryFormatter in that version. So the legacy code works, and a lot of devs, especially application developers, thinks, you know, if it works, don't touch it, right? The CVE, the actual CVE, the CVSS was 8.4. Does anybody, real quick, does everybody know what CVEs and CVSSs are? Okay, real quick. CVE is a common vulnerability enumeration. It's basically a log, a database of every vulnerability that comes out. It's date stamped and instance stamped with the year and the number of the vulnerability that was found. And this is going to have a proof of concept. It's going to tell you what kind of vulnerability is. It's a great database to look through. And then it's scored with a common vulnerability score, and this is 8.4, which means it's high exploitation. The next one would be critical. If you want to know more about the details of these, I get in that to my talk tomorrow. They were supposed to happen in a different order, so apologize for that. But anyways, this one had a CVSS of 8.4. It affected a particular version, which is 1.3 3, I think. And then you basically would get a local RCE based off of the IPC deserialization. So it's a real vulnerability in 2025 based on BinaryFormatter that was removed. So very quickly, this is how the attack works. You've got a malicious process. This could be anything. It could be a USB key insert. It could be a PowerShell script. Whatever that process is can send an IPC message, because any app can send that message across. You send it to the application of Greenshot. It uses BinaryFormatter to deserialize and then does whatever it is that's in your payload. In this case, would be remote code execution, which could be in most proof of concepts as a calculator. And this was their code. It's still up on GitHub. You can look at the tags. But in the vulnerable version, you see this. And in the invulnerable or the fixed, you see this. Does anybody? I've got the comments there. Never mind. I spoiled it. But if you noticed, it's a trust then verify versus verify and then execute. You notice that difference? It's just an order, right? They sit here and they deserialize and then they check whether it's an authorized sender versus the opposite. It's a very simple coding mistake. Okay, I promised demos, so everybody say a little prayer to the demo gods, and we will jump over to maybe we will. Nope. There it is. You see how I was so ready for this, right? There it is. Had to find the window. All right. Bring this guy over here. OK. So this is Greenshot running here. This is the, let me go over here before I can see. So this is just to show you the settings. It's actually a taskbar, so it sits down here. In here, I've got 2 files. I've got a C# file, which is my malicious process that I've compiled into an executable, and then I've got my actual payload. What I do want to show you real quick is, OK, so this is how we generate a payload. This is, if you look at the PowerShell script, this script is got a lot of nice comments in it. But here I've got a payload, right, that I'm going to basically run BinaryFormatter, chain it to a gadget chain, and then run my command. And the command that I'm running is basically a calculator. I'm just going to throw up a calc. And we basically convert it and get a payload. This can also be just done on the command line. It just makes it easier to see this way. And then for the C# file, very straightforward. It's hard to find the window for Greenshot. It doesn't just show up very easily, so I'm doing some searching to make sure I find the right window. And then I'm going to create a message, and that message, once it runs, hold on, will take the payload, which is a base64, and then send it, and then write to the console. And all right. I'm going to post this all up on GitHub after this so that if you want to play around with it, run it on your local computer, go ahead. I don't mind. All right, let's switch back over and actually run it. So, all right. Go up here. It's really hard to see. Everybody notice no calculator running. I'm going to run this. And that's it. It's very straightforward. So a simple script and a PowerShell to generate the payload. And you'll see it finds the process, loads the payload, finds the window, sends the copy data or the IPC, and pops the calculator. So now, if you imagine, you can put any kind of process you want on this computer and run it, just because of Greenshot. Now, if you update to the latest version, this won't happen anymore. But this version was, it's still available. You can still grab the package if you want to test it. But I think it got fixed about 2 months ago. So this was still a vulnerable, still open, till about 2 months ago. All right. OK, so the key to this, sorry, this is just for me to run my mouth. Legacy applications, right? They persist. Whatever tooling they built on, that's going to persist unless they change it. So these vulnerable applications are out there. The timeline for this, for BinaryFormatter, is long. It's, let's see, it was 2020, it was deprecated. 2025, we're still getting vulnerabilities, still getting reported CVEs. This is to show that BinaryFormatter, which most of you might be familiar with on web endpoints, is available in IPC. It's available in applications on anyone that runs it. So there's more landscape for you to play with as a researcher. So the question to think about is, how many other desktops applications are out there running that still run BinaryFormatter? We don't know. We don't have telemetry data. There's no Shodan for applications. But if Greenshot has 3 million users and they still had this, I imagine that there are a lot of smaller applications that also have this same kind of vulnerability. OK, so desktop apps are using BinaryFormatter, but we talk about web applications. We start to talk about JSON.NET. And JSON.NET or Newtonsoft has a little bit of a different story, not really removal, but it's a vulnerability that took 6 years to get a CVE. So it had no vulnerabilities reported whatsoever until it was last year, I think, 2024. So there's 2 stories with JSON.NET that I kind of want to look at. The first is type handling or type name handling all. How many of you do that in your applications? Good. You should never raise your hand for that. Please don't ever say that. And if you do, there are some things you can do, but try not to. And the other is a max depth issue that created an opportunity for denial of service attacks. So that attack was discovered in 2018. It was fixed in 2021 by one of the community members. And then it finally got a CVE. I say finally in 2024. So same library, same problem, different timelines. So I want to look at them both. Type name handling has been known since 2017. It has no CVE assigned. It is still in production code, but it is still very, very dangerous, right? It's widely documented. People show it at conferences. You see it in security audits. But it's curious why it still doesn't have a CVE. This is what the dangerous part looks like, right? The key here is that this is not the default. The default is safe. It's none. That's what it's set to. So you have to go in there and manually make it all for type handling. So if you leave it alone, you don't have a problem. But as soon as you change it, you have a problem. So basically, if they send JSON and they change the type to say system diagnostics process, JSON.NET will then create that object. And then that object can be using gadget chains, just like BinaryFormatter, to execute code. So now that one, most people don't have problems with. In fact, if you're using modern ecosystem like .NET 8 and beyond, you got no problem. And I'll show you that. But there was one of the JSON.NET vulnerability that did get a CVE. It took 6 years. So this particular CVE is about denial of service. So it was discovered in 2018, and then it was fixed in 2021. Now, the fix is really awesome. If you look at the repository for JSON.NET or for Newtonsoft, it was a quiet fix. It wasn't flagged as a security fix. It was just flagged as a feature, not even a bug, just a feature. And it was one of the community members that fixed it and said, hey, we're gonna sort it out. And then 2024, we actually ended up getting a CVE because of the defaults not being there for everything. So the cool thing is that the fix happened before the CVE, which means the community did what they were supposed to do before it was found as a vulnerability. The issue was this sort of dichotomy. max depth was missing. That's the library's fault, right? That's a vulnerability. But type name handling all, that's a choice, right? The defaults weren't there. So we don't get a CVE when it's a developer's choice unless it's in a library, right? Then we get something that's a package that has a version that's out there that's vulnerable. So that's why we ended up getting it, because the library was at fault. The fix was really interesting, really simple. They just added max depth. Before, there was no max depth. You could send payloads, nested JSON as long as you want. But the max depth of 32, that fixed it. This was in 13.0.3. It was fixed because if you think about it, legitimate use cases of this don't exceed 32 on average. But if you want to make it larger, you can. But nobody's going to DOS even at 1,000 nested. So there was no breaking changes for normal usage. It was transparent. But you had to upgrade, which seems to be a problem. OK, real quick. The evolution of this is straightforward. Anywhere from 9 to 12, it was vulnerable by default. JSON.NET 13 and beyond 13.03 was patched with a max depth. But then what we all should be using is secure by default, which is wonderful. So this, to me, shows ecosystem maturity, right? Each generation learned from the previous one. And because that is now the default from the start, that's why Microsoft recommends it and why you should be using it. OK, just like BinaryFormatter, we're going to be dealing with this for a while, probably a decade. So .NET Framework 4X supported still until 2034. So this is still going to be out there in some cases. The Shodan percentages showed me that of the .NETs that I could find, about 34, 35% of these applications that are out there running in the wild are still on Framework. I don't know if you guys have ever explored Shodan. Should not be showing how to use it up here. But you should explore it in your free time. You can sort of get a map of the internet and see what everybody's running. OK, real quick, the timeline. You can actually see what versions you're using just by the way it's managed. If this is wrong, I apologize. But I think that should be correct. So it's not that Newtonsoft is bad, right? But now that System.Text.Json is there, you should be using that. It's learned from the lessons. So, all right, move to another quick demo. This one is actually quite interesting because I spent a lot of time trying to get it to DOS, and I had to put it on Framework to be able to get it to run a DOS. Because if you're using modern .NET, it actually handles it on the architecture side. So it's not even possible, even if you're running the vulnerable versions. And I'll show you that it will deserialize, but it will handle it. OK. Right now, I've got a Docker log running on a vulnerable container, which is running a previous version. I am going to real quick check the health of it. Go. Perfect. Sorry about this. Just got to get it all set. All right. OK, so let's see. What are we running? 8093? OK, so 8093 is going to be the vulnerable container. And I just wrote a quick API to be able to look at this. OK, so the response, it'll just basically say this is the version that it's running, 12.0.3. So there's not going to be a max depth default. And then what I want to show you is kind of what the payloads look like. So if I do, and I'm going to do, whoop. OK, so I've basically created a bunch of different payloads. Each of these have nested depths. If you want to take a look at one, we can see, let's see. Oh, there we go. When you get older, you have to have two pairs of glasses, one that you can see in the distance and one you can see up close. So when I'm having to do this, it's really quite fun for me. So also need to go to the right folder. OK, so you can see that this is just nested data sitting in a bunch of brackets. I'll bring one up that's a little bit bigger so you can kind of see. 10,000 would be ridiculous. But so if you take this payload, right, and you send it to a vulnerable endpoint running on Framework, it will bring it down because Framework doesn't handle that amount of data well with deserialization and JSON.NET, so it will crash it. But if let's see. I already have this. I think that's the right one. Is that an 8092 or is that an 8093? I can't see that. No, that's not the right one. There we go. OK, so let's start by sending a real quick the 5. OK, so this is fine. If you actually look at the logs, you'll see everything went through. We've got a warning for the vulnerability. But then if you send through something a little larger, you're going to get, this handles it because it's .NET 8. But basically, this is how simple it is for you to send this vulnerability. Sadly, it's not going to crash because .NET 8 is smarter than Framework about this stuff. And then if you take this same one, and I'm going to show you a couple of different endpoints. I have one that does it with Newtonsoft. Let's see here. All right, so we've got a Newtonsoft safe. We're going to need to look at the other container. All right. So if you notice after I sent this, it already gives me a warning that says that the max depth has been exceeded. And then if I send the same one, but I'm going to send it to, well, actually, I meant to show you the safe one first. If you send 100 here, that's going to give us back a little something different, right? So the max depth here, I configured it to 128. This will show you that you can change the max depth. It's not going to throw any warnings. But if you send it to just straight, I really wish I could see this. It's a regular Newtonsoft, but you'll actually get the default blocking it. So the nice part about this is that if you change versions, by default, it will block it. You can change it now. You can set a max depth. If you're running .NET 8, it's safe. But if you're on Framework, you can still get a DOS. And the fact that you can get a denial of service allowed us to get a CVE. All right, let's switch out of here. I know that one wasn't quite as exciting as the other one. OK, so the deal here is that the CVE numbers, which is how we become aware of things, CVEs link to OWASP, link to awareness. They end up getting news. That's how we as devs start to see what these vulnerabilities are. But this took 6 years from the discovery of the vulnerability to a CVE. So if we don't get awareness, we end up with 6 years of possible attacks. So it's very important to sort of stay ahead of the curve as best you can and not just rely on exposed vulnerabilities. OK, so the next part of this is something that I found very interesting. We had JSON.NET giving a DOS, took 6 years. But SharePoint, it took 3 days. It took 3 days from the moment it was exposed to it being patched, dealt with, CVEs, like no expense spared. So let's talk about the 0 day for a little bit. So while I was looking at this, this happened in July of this year, 2025. It caught my attention because it wasn't theoretical, it wasn't fixed, it wasn't patched, it was something legacy, but that existed in a lot of real-world environments. When I was researching for the next talk, not knowing what OWASP has for their data, the only data we have for actual exposures is the CISA's known exposures database, or exploited database, and those exploits drive everything. When something gets actually exploited in the wild, it gets added to this catalog, and this was one that got added literally this year. So it was pretty fantastic. Sorry, maybe that's the wrong word. It was very interesting. Fantastic for some. So this affected SharePoint servers from 2016, only on-prem, right? But if you think about it, most of the time that people are running on-prem, most of their head is around securing their data, keeping it off the cloud. Somehow they connect it to the internet, and this vulnerability allows exposure. All right, so the CVSS itself was marked as a 9.8, which means it was critical. It was an unauthenticated RCE, which is the worst kind. And it was 2 components. So it was actually an authorization bypass, and then after the bypass, it was deserialization. So, all right, let's get a little further. The threat actors were really great in this one. This would be Storm 2603, which is Microsoft's way of saying more Chinese nation-state actors. So other people using this, Linen Typhoon, Violet Typhoon, all Chinese nation-state. That's what we think. There's no absolute proof, but pretty close. They deployed malware, so there was a Warlock ransomware, there were web shells deployed, and lots of persistent access tools. And it has been happening since March of 2025, so March of this year. Usually motivations, financial, or espionage. Now, the attack is sort of two-part with an asterisk. The first is bypassing authentication, which with this particular instance of SharePoint, it was very easy. It's unauthenticated bypass just by changing a referrer. And then ultimately you're going to forge the view state with gadget change, which is using LOS formatter. By the way, I'm from Florida, and so every time I saw LOS formatter, I kept wanting to say LOS formatter, and that kept messing me up, so I've had to ask a few people about that. But the key here is that view state is usually signed, which means that if you don't have the keys, you can send through a payload, but it's not going to work because it's signed and it's going to reject it. But a lot of the times you can either extract a machine key or find a leaked exchange key. That's what happened in another one we'll talk about. But in this case, I think most of the keys were leaked in some cases through a web config, just some kind of backup that was living on a server. Or actually, the original one of this was them putting a vulnerable piece of code on the computer in order to get the keys extracted. So let's jump through this real quick. Sorry, I'm going to run out of time to show the demo. The second part of this was, after you get the keys, it was the deserialization. So you've got a key. Once you have a key, you can sign any payload you want. So you ultimately have kind of keys to the kingdom to do whatever you like within ViewState. Because with this key, the attacker crafts the valid, crafts signed malicious code, and SharePoint will deserialize that in this particular version before the patch, before validation. So because of that, you end up with RCE. So the lesson here, before we really even get into it further, is defense in depth. So there is no layered approach to this. There was weak authorization, there was exposed secrets, and there was unsafe deserialization. So all 3 had to fail to be able to make this exploit happen, and it did. So the serialization tie is this. ViewState uses LOS formatter. LOS formatter uses BinaryFormatter, so that means the same gadget chains work. So that the vulnerability itself will persist even after removal, because with the deserialization, you can put things that allow you as an attacker to keep a foothold and keep persistence on servers. So I'm sure you guys have seen these keys, right? It's very straightforward, a validation and decryption. If these get leaked somehow, this is where it gets dangerous. So that's one of the flaws. This can happen in a couple different ways. You could do like a backup file, web.config back. You can find it in the source control, right? You can search GitHub for keys like this. GitHub's been really good about removing these, so they'll automatically find them, wipe them out. It's really good. So many of those things have been helped tremendously by GitHub's scanning of repositories as they get pushed. Blessings for that. And then so honestly, once you have the key, game is over, and you can do whatever you like. The timeline for this was kind of interesting, right? It was actually not the exact same issue, but it was found at Pondeon in Berlin. There were some researchers that were able to get remote code execution through ViewState. It wasn't SharePoint, but it was basically showing that, hey, I've got these keys, I can bypass this, and I get RCE. And because of that, Microsoft did a patch and a disclosure ahead of time before anything ever happened because of this program. So if you haven't heard of this, a lot of companies participate, and they have researchers attack, find exposures, and then patch them before they ever get out into the wild, just because of a conference. And then once the patch was released, somehow the information from these hackers that were disclosing in the correct way made it out into the wild, and people started searching for it and found that vulnerability in on-prem SharePoint. So once that 0-day was discovered, it was a sort of a bypass variant of that, and then we got active exploitation automatically observed. Once we started searching logs, we were able to find that. And then in July, the 20th, immediately there was emergency response. It was added to the known exploited vulnerabilities by CISA, and then it was escalated to critical. And then after that, 4 days, it was ransomware was deployed. So honestly, this is the one that kills me at the end. That's just looking at a vulnerable version of SharePoint. Whether or not it's patched, I don't know. It's unknown, but I did that before I flew over here. So there are still 29,000 SharePoint servers connected with that version that may or may not be patched out in the wild. So it's still out there. Now, this is the demo that I hope works, and so cross your fingers for me. So I wrote a mock SharePoint because running that is very resource intensive in Docker or in a VM. So, and I don't have those resources on this Air. So let's switch over and take a look at that. All right. Bring this over. Okay, this is my fake SharePoint. But what you'll see is that you've got the tool configuration, which takes you to, let's click on this, this URL, layouts, tool pane, and in the tool pane, it is access denied. So authorization is required for this. Now I am going to bring up one of my favorites, maybe. There are lots of different ways to do this, but visually, this is going to be the easiest to show. Bring up burp. You turn on intercept, right? So I've got my browser open, turn on the intercept, and this will allow me to intercept the requests as they come in. Okay, you'll see here's the request coming in. And then I'm going to take this and I'm going to send it to the repeater. Okay, so now we actually have the request. And if you look at the actual source of this, sorry, let me go back here. Ooh, that's really hard to see. All right. All right. Everybody see this? So there is our view state. This is the actual value that's here. So this is the expected amount, the payload, and then this is our generator, right? So in order for this to work, in order for us to be able to send our own payload, we have to have the keys, right? And we don't have the keys. Now, finding the keys is, it could happen, it might not happen. And since this is a demo, I made sure that it will happen. And the way I've done this is I created this dictionary, which is basically a list of endpoints that I'm looking for. Just a long file. This one's very small if you've ever looked at text dictionaries for attacks. And then I'm going to crawl this. Let's see, am I in the right folder? Yeah, I think that's right. And then look for everything in that dictionary to see if it exists on that server. So I just really quickly test the endpoints. All I'm looking for is 200s. And you can see I've got two 200s that are on that server, just so you can get a better look at them. All right, so there they are. Webconfig.back. You think that's a good thing to be on the server? It is for me. So let's take a look at what that looks like. So let's say that's exposed, right? This is so fake, but it's possible, so don't worry about it. What do we see up here, right? We've got our backup, we've got our machine key, our decryption key, and after we have that, we can do whatever we like. There is, if you go here, I'll show you real quick. I did the same thing with this payload, but for SharePoint. In this case, I've already hard-coded everything that was from this. But here's the actual command, this line right here. This can be run in a terminal by this open source program. But I have the actual generator, which we saw on the website, right? And then I have my validation key and the actual algorithm used. Once we have that, we're going to create a payload. And my payload, right, is to echo this out and write it to where? To the root, SharePoint, and a text file. Now, if I can write a text file to the server, what does that tell me? It means I can do whatever I like. So let's see if we can get this to work. So. All right. All right, let's see, which one am I using here? Not that one. There it is. Now wow, having problems typing today. All right, so if you take a look at this, it's significantly larger than that other one that we saw, right? Can't really read it. You could run strings on it. You can decode it because it's base 64. But we're going to take this payload, which is signed, and we're going to send it. So let's see. All right. Now we're in burp. And then, oop, that's the wrong one. Sorry, 1 second. Anybody see a post? We haven't gone the, sorry, I haven't done the auth bypass yet. Let's do that first. So we'll go here. Remember, this is a two-part. We're going to send it to a repeater. And then here, I cannot see this to save my life. Anybody see our refer header here? Don't see that yet. You see it? There it is. Yeah. This is the right one. And then we're going to do, let's see, I think it's underscore layouts 15. And then I think it's sign out.aspx. Let's see. All right, let's see here. I think that should be right. And then if we head back to our site, oh, intercept's still on. Sorry, guys. See, this is the live demo gods telling me I didn't practice this enough. I think that's right. Yeah. There we go. Like I said, not doing what I wanted it to do. All right, let's just do it from in here. Let's see. Do we have? Yeah, so here we've actually, if you look at this, let me see, do a render. Okay, so we've already bypassed the auth inside of burp. So that means we've gotten to the first part. So the next part, if we take this same one and we look at the raw here. All right. All right, well, I'm not getting what I want here. I so apologize. All right, well, I'm not getting what I want. So unfortunately, that is not working. So just 1 second. Anybody here smarter than me knows what's happening here? Usually the cookie persists here. All right, well, 1 second, unfortunately. Yeah, that's, like I said. 1 sec. Well, I had a feeling this was going to happen, so I apologize for struggling up here for you. All right. Anybody better at burp than I am can tell me where this exploit needs to go? All right. Well, anybody raise their hand on that one? No? Okay. So I'm gonna bail out of this. I apologize that we weren't able to do it. So once you bypass the auth, you're basically just sending that payload over, and it's going to write that text file. The deal here that was problematic for me is that this exact same pattern was found in Sitecore, and Sitecore was September, so not even a month ago. The exact same vulnerability, ViewState deserialization, but the exposed keys here were a little bit different. Instead of finding them on web config, they found it in the documentation. People were using the tutorial from Sitecore, the keys from the tutorial in production. So by using the default, so to speak, tutorial keys or the documentation keys in production, attackers already had the keys available to them, and they just tested it. They were like, what if we tried this? And they did, and they were able to get the exact same deserialization attack, also using ViewState, also exposed keys. So there was a known vulnerability that was exploited. So it's not a SharePoint bug. It's not a Sitecore bug. It's just a class affecting anything that uses web forms from ASP.NET using ViewState, as long as you have the keys, the exposed keys. So the key here is that these related serializers are going to persist, no matter what we do. There's always going to be something out there that's legacy. There's always going to be something out there that is attackable. So we have to be careful as we're writing, as we're using these things, to always sanitize and to always think about it before we publish to production. So if you deprecate one, it doesn't eliminate related ones, and it's sort of a wider issue than we might have think. So you can't just grep code for BinaryFormatter and find all of this. All right, so let's take a look at this. We've got 3 different vulnerabilities just to deal with deserialization and serialization. One is BinaryFormatter that took 22 years. JSON.NET took 6 years, and ViewState took 3 days. The patches are available. Everything is out there, but it's all about being aware. The guidance exists, the fixes exist, but we have to patch the code. No shame here, but we do all actually know better. Most of you here have never been the victim of Git blame, and that's a good thing. The truth is the vulnerabilities persist. They're in production. They're there right now. So we have the knowledge. We've got tools. We've got guidance. It's up to us to sort of make other people aware of these things because we can't rely on the ecosystem to fix it soon enough. Because if it takes 22 years or 6 years or a really, really bad one that takes 3 days, if we talk about it and we work on these things together, we can actually fix them. So the what not to do's, it's really about asking questions, not don't do this, do this. It's can you avoid it entirely, right? If you can avoid it entirely, great. What's the safest format that you can send, right? Do you really need polymorphism? If you do, explicit allow lists. Are you stuck with legacy? Because some of you might be, depending on who you work for. It's all about defense in depth, right? It's all about layers of cheese. Not everything's going to slip through. Try not to use BinaryFormatter. Try never to do type name handling of all. Try to always use System.Text.Json, max depth, and by all means, please validate everything. The reality here is that it is going to persist for Framework 4 until 2034. After that, it'll still exist, but it's hopefully not going to be supported. Searching for .NET Framework apps out there, there's still, like I said, I found 35%. It's not pessimism, right? This is, in my opinion, planning. You know timelines, and you know how to defend it appropriately. The real key here is to never trust user input, right? We can't eliminate legacy code overnight. We can understand why it persists. We can look for the risks, know where the risks are. We know how to defend it while it's around. And that's hopefully what these stories have taught you guys. That's what it taught me. So with that, thank you. I will try to answer questions as best I can. Appreciate it. Thank you.